So in this lesson, we're going to take a short break from complex numbers. We're going to look at an alternative way of measuring angles called radians. We're going to look at how to convert angles between radians and degrees. The reason for that is because a lot of the work we're going to do on complex numbers will measure the argument in radians, so we need to understand how they work. You will also find that radians will come up in normal maths, but not until later on in the course. So radians are an alternative way of measuring angles instead of measuring them in degrees. It's a bit like if you were going to measure the length of a straight line, you could either measure it in centimetres or inches. And although the actual straight line would be the same, you would get two different answers depending on which unit you were going to use. So basically a radian comes from the idea that if you take a circle and take its radius there, imagine that its radius was a piece of string. You picked up that piece of string and you wrapped it around the circumference to form an arc. So that piece of string is going to go around there. So the length of that arc is r. Now if you then draw in the rest of the sector, that length will be r as well because it's also the radius. The angle that you've formed at the centre there is called 1 radian. Okay, so the symbol for radian, we often use a little c instead of a degrees sign. The reason for that, the c stands for circular measure because it comes from the idea of the radius of a circle. So the question is, how many radii is just the plural of radius, how many radii could we fit around that circumference of the circle if we were to keep drawing them round? So we could put another radian there, another radian there. And you can see it's 6 and a bit, 6 point something radii would go around the circumference. We can calculate that more accurately because we know the formula for the circumference of a circle. It's either pi d or 2 pi r if we're working with the radius. So if we divide the length of the circumference by the length of the radius, that should tell us how many radii we could fit around the circumference. So the circumference is 2 pi r. Radius is just r, so the r's are going to cancel in that fraction, leaving us just with 2 pi. So 2 pi is the number of radii we can fit around the circumference, or it's the number of radians that makes a full turn. So we know that pi is the number 3.14, so 2 pi is the number 6.28 something. That looks sensible on the diagram. You can see that 6 point something is the number of radii we've got around the circumference there. Okay, so the number of radians in a full circle is 2 pi. So therefore we can say that 2 pi radians is the same as 360 degrees. Okay, so we can now convert between radians and degrees. We've got a starting point. We know that 2 pi radians is the same as 360 degrees. They're both a full turn. So just dividing both those numbers by 2, we get that pi radians, remember that pi is 3.14-ish, so pi radians is 180 degrees. And then from there, we can just multiply or divide to get any other value we like. So some of the common ones, for example, we could divide by 2. And we get pi by 2 radians. We're going to use the c for radians. Divide 180 by 2, get 90 degrees. We could start with pi and divide by 6. And divide the other side by 6. And we get pi by 6 radians equals 180 divided by 6 is 30. Notice that if possible, we tend to try to write them in terms of fractions of radians, like pi by 2, pi by 6, and so on. However, angles in radians don't have to be measured in terms of multiples of pi. So for example, if we started with pi radians equals 180 degrees and divided by pi, so divide by pi, if we divide the other side by pi, well, pi divided by pi is just 1, so 1 radian equals, I'm just going to do 180 divided by pi on a calculator, and that is 57.3 to 1 decimal place. which fits in with what we saw earlier, where it looked like it was just a little bit less than 60 degrees because we could fit just over 6 of them into a full turn. Okay, so not all angles measured in radians have to be in terms of pi, but they often are, just because it makes it simpler to use. So using the fact that 360 degrees is 2 pi radians as a starting point, I'd like to pause the PowerPoint and just fill in the rest of the table, calculating the values in radians. There's also a formula for converting angles between radians and degrees. Using the fact that we know 2 pi radians is 360 degrees, therefore pi radians is 180 degrees. We can start with any angle measured in radians. If we divide by pi and multiply by 180 in either order, we will end up with the angle in degrees. If we start with the angle in degrees, if we divide by 180 and multiply by pi, again in either order, you will end up with the angle in radians.